Hello viewers, in today's class we are going to discuss another problem from integral inequalities. So in this lecture we have one very important problem from estimation of integrals. So here we have to prove that the value of this integral that is from pi by 4 to pi by 3 sine x over x, it lies between square root of 3 over 8 and square root of 2 over 6, right? So we'll prove how to prove that the value of this integral, it lies between these two numbers. So let us start. So now let us take this integral as I. So here we have the integral I, that is from pi by 4 to pi by 3, and the integrand is sine x over x dx, right? So let us take a is equal to pi by 4, the lower limit, and the upper limit is pi by 3, and the integrand as f of x, that is sine x over x. So here I will make use of an important theorem from integral inequalities, and the theorem goes like this. The integral of f of x from a to b is greater than or equal to small m times b minus a, and it is less than or equal to capital M times b minus a, right? So this is a very important inequality which is used to solve a lot of these kind of integral inequalities. So here this f of x is sine x over x, right? A is pi by 4, b is pi by 3, right? Now this small m is the absolute minimum of f of x, right? So the small m is the absolute minimum or the global minimum of this function f of x in the interval that is a comma b, right? And this capital M is the absolute maximum value of f of x in the interval a comma b, right? So the small m is the global minimum and the capital M is the global maximum value of this function f of x in the interval a comma b. So now let us substitute the values from here to this inequality, right? See, we do not know the value of small m and capital M, and we are going to find out the value of small m and capital M. So now we can write m b minus a. B minus a can be obtained as pi by 3 minus pi by 4. So this is 12. The LCM is 12. We have 4 pi minus 3 pi. That is pi over 12. Right? So we have m times pi over 12. And here we have the integral from pi by 4 to pi by 3 sine x over x dx. And here we have capital M times pi by 12. Right? So now once we find the value of small m and capital M, we can easily arrive at this inequality, right? So to get the value of small m and capital M, let us investigate this function f of x, that is sine x over x. So let us differentiate f of x with respect to x, right? So f prime of x is the derivative of sine x over x, and here I will make use of the quotient rule. So we have x, the derivative of sine x is cos x minus sine x, and then the derivative of x is 1 divided by x square, right? So we have x cos x minus sine x divided by x square. So now let us take cosine of x common in the numerator. We have cos x, then we have x minus sine x over cos x divided by x square, right? So this can be written as cosine x over x square, and here we have x minus tangent of x, right? So the derivative of f of x is f prime of x, which is equal to cosine x over x square, x minus tangent of x. So now from this expression, we can easily see that in the interval that is from pi by 4 to pi by 3, right? Actually, pi by 4 is 45 degrees and pi by 3 is 60 degrees, right? And we are in the first quadrant, right? Okay, so in this interval, we can see that cosine of x is positive, right? And x square is positive, and here we have x minus tangent of x, right? And we can easily see that in the interval 45 degree to 60 degrees, this x is less than tan x, right? It means x minus tangent of x is less than 0. We can verify this result by taking some particular value of x lying between this interval. For example, say, let us take x is equal to pi by 4, right? See, here we have pi by 4, and tan pi by 4 is 1, right? And if we divide 3.14 by 4 minus 1, so this quantity is obviously less than 1. So this is less than 0 or a negative quantity, right? So x minus tan x is less than 0. So here we have a negative sign. So we can now conclude that f prime of x is a negative quantity, or it is less than 0 in this interval that is from pi by 4 to pi by 3. So the derivative of f of x, which is f prime of x, is less than 0 in this interval. So this suggests that f of x is a decreasing function in the interval pi by 4 to pi by 3, right? So this is the investigation about this function f of x. So we have concluded that this function is a decreasing function in this interval, right? So the value of absolute minimum can be obtained in the for x is equal to pi by 3. So viewers, f of x is a decreasing function. So the value of m can be obtained at this value of x, right? So for x is equal to pi by 3, we'll get the absolute minimum because f of x is a decreasing function. And for x is equal to pi by 4, we'll get the maximum or the absolute maximum value of this function f of x, right? So m is now equal to sine that is pi by 3 divided by pi by 3. So sine pi by 3 is sine 60 degrees, and that is equal to root 3 over 2. So this is pi by 3. So this is 3 root 3 over 2 pi, right? Okay. Now the value of capital M can be obtained at this value, that is pi by 4. So we have sine pi by 4 divided by pi by 4. Sine pi by 4 is 1 over root 2. This is pi over 4. So this is 4 over pi times square root of 2, right? So now we'll substitute these values in this inequality. So now we can write this inequality as m times pi by 12. M is 3 root 3 over 2 pi times pi over 12 less than or equal to this integral. We can write this integral as I, and we have here m is 4 over pi root 2 times pi over 12, right? So now this is 3 fours are 12, and here pi and pi get cancelled. So we are left with root 3 over 8. 2 times 4 is 8. And here we have 4 threes are 12. So we have pi and pi get cancelled. So we have here 1 over 3 times square root of 2. So now this term 1 over 3 root 2 can be written as 1 over 3 root 2 times square root of 2 over square root of 2, rationalizing the numerator and denominator. So this is root 2 over root 2 times root 2 is 2. So this is 3 times 2, so root 2 over 6, right? So we have root 3 over 8 less than or equal to I, that is less than or equal to root 2 over 6. So viewers, this is our desired inequality. Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integral inequalities, right? So in this class we'll prove this inequality, that is we are given an integral I from 0 to 1 square root of x raised to 4 plus 2, and here we have to prove that the value of this integral I is greater than or equal to square root of 2 but less than or equal to square root of 3, right? So without actually evaluating this integral, we have to estimate the value of this integral I between these two numbers. So viewers, here we have to estimate this integral, and we have to show that the value of this integral lies between square root of 2 and square root of 3, right? And here we are not going to evaluate this integral. So we'll prove this inequality with the help of an important result from integrals, that is known as the mean value theorem for integrals, right? So the mean value theorem for integrals says that if we have a closed interval, say a comma b, right, and we are having a function, say y is equal to f of x, and this function is defined on this interval, and it is also continuous, right? So mean value theorem for integral says that the integral a to b f of x dx is equal to b minus a, that is the difference of upper limit and lower limit, multiplied f of alpha, right, where alpha is some number which lies between a and b, right? So this is the mean value theorem for integrals, and this is a very useful result for solving these kind of problems. So now if we compare this integral with this one, then we can see that the value of a is 0 and the value of b is 1, right? A is 0, b is equal to 1, and f of x is given by square root of x raised to 4 plus 2, right? So using this result, we can now write this integral I, that is 0 to 1 square root of x raised to 4 plus 2 dx is equal to b minus a, right? B is 1, a is 0, so we have 1 minus 0, and then multiplied with f of alpha, right? F of alpha, where alpha, this alpha is some number which lies between 0 and 1, right? So 1 minus 0 is simply 1. So we have 1 times f of alpha, that is equal to f of alpha, right? So our integral I is now equal to f of alpha, and f of x is equal to square root of x raised to 4 plus 2. So we can now write the value of f of alpha by simply replacing this x by alpha, right? So we have I is equal to square root of alpha raised to 4 plus 2. So now our I is equal to this quantity, that is square root of alpha raised to 4 plus 2, right? And now see here we have this inequality, that is alpha lies between 0 and 1, right? So what we will do, let us take the fourth power of all the terms in this inequality, right? So raising these three terms to the power of 4, we have 0 here, then we have alpha raised to 4, and here we have 1 raised to 4. So this is 0, this is alpha raised to 4, this is 1, right? Now see here we have alpha raised to 4 plus 2. So what we will do, let us add 2 throughout this inequality. So we have 0 plus 2, alpha raised to 4 plus 2, here we have 1 plus 2. So this is 0 plus 2 is 2, this is alpha raised to 4 plus 2, this is 1 plus 2, 3, right? Now here we have square root of alpha raised to 4 plus 2. So let us take the square root of all these three numbers, right? So we have square root of 2, square root of alpha raised to 4 plus 2, and here we have square root of 3, right? Now square root of alpha raised to 4 plus 2 is I, so we have square root of 2 I, and here we have square root of 3, and this is our desired inequality. So this inequality suggests that the value of this integral I, it lies between square root of 2 and square root of 3. So this is how, by making use of the mean value theorem for integrals, we can solve these kind of problems related to integral inequalities. Hello viewers, in today's class we are going to discuss another problem from integral inequalities, right? So in this lecture we'll see a very important problem from estimation of integrals, in which we are given an integral I is equal to 0 to 2 pi, and we have dx over 5 plus 3 cos x. Then we have to show that the value of this integral I, it satisfies this inequality, that is I is greater than or equal to pi by 4 but less than or equal to pi, right? So without evaluating this integral, we have to arrive at this inequality. So let us start. So viewers, whenever we have to estimate integrals or we have to solve these kind of problems related to integral inequalities, we usually make use of different identities related to integrals. But here to solve this problem, we'll use an important concept that is called mean value theorem for integrals, right? So mean value theorem for integrals is a very important uh, concept to prove these type of inequalities. So mean value theorem for integral says that if we have a function, say y is equal to f of x, and this function is continuous in the closed interval a comma b, then the value of this integral, this function f of x, that is the integral of f of x dx from x is equal to a to x is equal to b, is equal to b minus a times f of alpha, where alpha lies between a and b, right? So now if we compare this integral with this one, then f of x is equal to 1 over 5 plus 3 cos x, and the value of a is 0 and the value of b is 2 pi, right? So the lower limit is 0, the upper limit is 2 pi. So now using this mean value theorem, We can now write I, that is this integral, which is 0 to 2 pi dx over 5 plus 3 cos x, is equal to b minus a. B is 2 pi, a is 0, and f of alpha, right? Where alpha is some number which lies between 0 and 2 pi, right? So now we have this expression. So we can now write I, and here we have 2 pi minus 0 is 2 pi, and f of alpha, right? Okay. Now f of alpha can be written by replacing x by alpha. So we can now write I is equal to 2 pi times 1 over 5 plus 3 cos alpha. So we can now write I is equal to 2 pi over 5 plus 3 times cosine of alpha. So now we have this expression, right? Now let us make use of some trigonometry here. So we know that the value of cosine of alpha, it lies between minus 1 and 1. That is, the minimum value of cos alpha is minus 1, and the maximum value of cos alpha is 1, right? And whenever alpha belongs to this interval, that is 0 to 2 pi, right? Okay, now see, in the denominator we have 5 plus 3 cos alpha. So let us multiply this inequality throughout by 3. So we have here minus 3, 3 ones are 3, here we have 3 cos alpha, and here we have 3 ones are 3, right? Now here we have a term 5, right? So what we will do, we'll add 5 throughout this inequality. So we have minus 3 plus 5, 3 cos alpha plus 5, and here we have 3 plus 5, right? So 5 minus 3 is 2, and here we have 5 plus 3 cos alpha, this is 8, right? So using this fundamental inequality from trigonometry, we have arrived at this inequality. So now let us divide this inequality throughout by 2 pi, because here we have a factor 2 pi, right? So what we will get here, we have 2 over 2 pi, then we have 5 plus 3 cos alpha divided by 2 pi, and here we have 8 divided by 2 pi, right? Now here we can cancel the common terms. So here we have 1 over pi, then we have 5 plus 3 cos alpha over 2 pi, which can be written as 1 over I, right? Because I is 2 pi over 5 plus 3 cos alpha, and we can now write here the reciprocal of I, right? So this is 2 4s, so this is 4 over pi. So now let us take the reciprocal of all these three terms, right? So when we take the reciprocal of these three terms, then the direction of the inequality get reversed. So here we have pi, then here we have the sign of greater than or equal to, then here we have I, and here also the direction get reversed. So we have pi over 4, right? So we can also write this inequality as pi by 4 is less than or equal to I, that is less than or equal to pi, right? So this is our desired inequality which is to be proved. So viewers, this is how, by making use of the mean value theorem for integrals, we can solve these kind of integral inequalities.